Hey everybody, this is Mr. Piercy, and I'm making this video to assist you with some of the homework problems on your 7.2 and 7.3 assignment. Yesterday and in the office hours and the day before and late last night, I was getting a lot of questions about some of the problems on those two assignments. And I thought it would be easiest to make a video demonstrating some of the commonly asked questions that I've been getting. So that way, if you're not sure about something, you can watch this video and try and get some clarification on what we're going to be doing. So let me go ahead and get myself set up here. All right. Here, the first few problems are going to come from the 7.2 assignment. This is one of the reasons why I was saying you must show me your work on your assignments in order to receive full credit. I was particularly thinking about problems 7 through, I believe it was 12. Yeah, 7 through 12. So here's problem number 8 that I will look at as an example for you. Here, coordinates A would be at 8, -4, so 2, 4, 6, 8, 2, 4. So here's A, and then B is at -5, -2, 2, 4, 5, -2, somewhere about there. And C, -1, -7, so -1, 2, 4, 6, 7, so somewhere about there. So here's B, here's C. Now, looking at the figure, or looking at the instructions in the problem, you're being asked to classify, is this triangle an acute triangle, a right triangle, or an obtuse triangle? I want to be 100% clear on this. If you tell me that this is a right, acute, or obtuse triangle without the appropriate math that justifies that statement, you will not receive any credit for your answer. I don't care if it's right or not. You must be able to say it is this, and this is the reason why. You cannot say it is this type of triangle because it looks like that. That is not an acceptable answer in a geometry curriculum. Okay? So if I want to know what type of triangle is this, all right, well, the converse of the Pythagorean theorem, which is what we're talking about, if c squared is equal to a squared and b squared, well, that's right. If, however, c squared is less than a squared and b squared, that means it's acute. And if c squared is greater than a squared and b squared, then it's obtuse. If you're trying to tell me the triangle is right, acute, or obtuse when the assessment or when the assignment is about the converse of the Pythagorean theorem, if you do not show me that, you will not receive credit because that's what the questions are asking. So because these coordinates produce a triangle on a plane, we don't know how long the sides are. So you have to do the distance formula first to figure out how long each side is. Now I'm not going to work out the distance formula for each one. However, AB, when you work it out, is the square root of 13 units long. BC, when you work out its distance, is the square root of 41 units long. And CA, when you work out its distance, is the square root of 58 units long. So the longest side does appear to be AC. So I'm going to substitute that into the formula. So I'm going to say C squared is something with A squared and B squared. So I'm going to substitute the square root of 58 here, making sure on my calculator I'm going to put the radical in parentheses, the entire thing. And here I'm going to say the other two sides. So I'll say square root of 13 squared plus square root of 41 squared. So the square root of 58 squared is just 58. Same thing with the radical 13 and 41. I'm just going to get 13 and 41 when I square those values. So on the left side, we just have 58. And on the, well, I can erase this equals or question mark here. 13 plus 41 is going to give me 54. So in this case, 58 is greater than 54, so c squared is greater than a squared and b squared. Now I have the justification to say that this triangle is obtuse. If you don't show me why it's right, why it's acute, or why it's obtuse, you will not receive credit for those problems. So please make sure if you need me to resend your assignment back before I grade it, let me know. Here's another one from 7.2. This is a common question that I've been asked. This is tying back into older material as far as the triangle inequality theorem. One of the things the triangle inequality theorem said, the longer the side, the bigger the angle. That's across from it. So here, let me see. Let me grab my calculator. I forgot to grab my calculator because I don't know exactly what 6 radical 6 is as a decimal. So 6 radical 6 as a decimal, we'll just say it's about 14.7. And then 2 radical 65 is about 16.1. So for instance, in question number 13, we want to know, is angle J equal to angle R, or is it greater than or less than angle R? Well, angle J and angle R both sit where clearly the biggest angle has to be because they're opposite of clearly the biggest side. But we don't know, at this point we don't know, are they equal to each other, less than or greater than? Well, because 14.7 is less than 16.1, then that means that angle J must be less than angle R. So I would just simply say that. And I would look at the same thing for whatever K plus L would be and whatever S plus T would be. We don't need to know the actual angle measurements there. We just need to know which ones are bigger than the other ones based off of the fact that the side across from them is either bigger or longer, because the size of the angle is determined by how long the side is. Now here on questions 15 through 20, this is a big thing that I've been given as far as I'm not sure what I'm doing here. Here's example number 20, or problem number 20. I'll work out as an example for you. Now, this algebra skill will be on your next test. So it's very important that you understand how to do these types of problems where the length of the side is represented with an expression and not just a number. Now the thing is that they're telling us in the problem that this is an acute triangle. So that means c squared has to be less than a squared and b squared. So this is a, this is b, and the 29 is c. So if I say, in this case, a squared plus b squared, in this case will have to be greater than c squared for it to be acute. So substituting the values, I'm going to substitute x plus 2 squared plus x plus 3 squared is going to be greater than 29 squared. Now I want to be clear because I have seen this a lot of times. X plus 2 squared is not equal to x squared plus 4. You cannot simply distribute the exponent into the parentheses because it would violate your order of operations. You must add the numbers inside of the parentheses before I can raise it to a power. However, anything that is squared in math, we're going to say, take whatever that thing is and multiply it by itself. So x plus 2 squared is x plus 2 times x plus 2. X plus 3 squared is x plus 3 times x plus 3. Now, depending on what your algebra teacher taught you, they may have given you an acronym called FOIL, or they may have given you a box, which looks like in biology, like a Punnett square. Either way, you're going to multiply the expressions together, x plus 2 times x plus 2 and x plus 3 times x plus 3. When I multiply x plus 2 times x plus 2, I'm going to get x squared plus 2x plus another 2x plus 4 when I multiply everything together. For the second multiplication, I'm going to get x squared plus 3x plus another 3x plus 9, and I forgot to square my 29 here. And so 29 squared is 841. At this point, we're going to combine our like terms. I have two x squared terms, 2x, 2x, 3x, and 3x. 4 plus 6 gives me 10 x's. And then I'm going to say 4 plus 9 to be 13. And all of that is greater than 841. Now, looking at the rest of the problem, what we have now is we have a quadratic expression. And the only way that I can solve for x in a quadratic expression is if I put it in standard form, where everything is on one side of the equal sign, or the inequality in this case. So at this point, I'm going to move the 841 from the right side of the inequality to the left side. And I'm going to get 2x squared plus 10x. And 13 minus 841 will give me a negative 828 to be greater than 0. Now, at this point, what we're going to do is factor the quadratic. Now, there's lots of ways that you could factor. You could leave it the way it is and factor it as it is. But if you recognize that the a, b, and b, or a, b, and c values, the 2, the 10, the negative 828, they're all even numbers. So I'm going to factor out a greatest common factor, which is 2, leaving me x squared plus 5x minus 414 to be greater than 0. Okay? At this point here, when we have, particularly what I'm doing is I want the a value, the number, the coefficient in front of x squared. I like that to be 1, which at this point now I have it that way. If you're having a difficult time remembering how to factor, ask yourself, what factors of c will add together to give me b? In this case, I'm going to look at the 414. I'm going to ask, what numbers could I multiply together to give me a 414, but would also add together to give me a positive 5? And in this case, the factors of 414 that would add together to equal a positive 5 would be if one is a positive 23 and the other is a negative 18. What we have here, we would refer, in an algebra course, I would refer to those as a factor of the quadratic. Each factor produces a solution to the problem. In algebra, you start talking about parabolas. Quadratic expressions give you a parabola when you graph it. So if I were to graph these, I would say I would have a solution at a negative 23 and a positive 18. And it would just kind of come down and do one of these things. Well, the solutions, first of all, there's two solutions because we have something x squared. And each individual factor gives me one of my solutions. So I'm going to set each solution In this, 23, not 3. In this case, I'm going to set each solution not equal to 0, but in this case, I'll say it's greater than 0. And I'm going to solve for x, moving 0. Moving the 23 over to the right side, I get x to be greater than negative 23 and x to be greater than positive 18. Now, these would both be correct solutions for an algebra problem. However, we're putting it in context of a triangle in a geometry setting. And it is not possible for me to have a negative solution to a problem in geometry that's going to represent an actual length of a triangle. So in this case, x would have to be greater than 18. So any values that are greater than 18 would be fine. Now, this one, I was actually really surprised the number of questions that I've gotten on this one. What is the length of the gutter to the roof peak? What we're looking for is this length right here. Well, we know that this is 15 feet. So the question is now, how long is this? Because I need to know how long that horizontal member is of the roof in order to be able to figure out the pitch of the roof. How long is the actual part that you would walk up if you're standing on your roof? And the solution comes from here. That is essentially, your slope, your rise and run. For every 5 feet you go up, you go over 12 feet. So since I went up 5 feet, or since I went up 15 feet, then this has to be 36 feet, because 15 over 36 would simplify to be 5 over 12. Well, doing the Pythagorean theorem, I'm going to get this number here, and that would be the value of the roof pitch. I'm not going to work that out for you. Once I know what that is, to find out how many rows of shingles I would need, I would convert my answer from 21, because the answer that you get is in feet. So you need to convert it into inches and then divide it by 5 to figure out how many rows of tiles or rows of shingles you would need to answer that one. So that's it. Those are the most common questions that I got on 7.2. Now let's take a look at 7.3. Common questions started around questions 10, really 10 through 15, because they're essentially the same thing. Tell whether the triangle is a right triangle. Well, let's just take a look at number 10. How do I know if this is a right triangle? If it is, I'm going to look at this side is A, this side is B, and this side is C. We don't know if it's a right triangle or not. So A squared, B squared, C squared, if we plug in the numbers and it works, then we know it will. So here I'm going to say 12 squared plus 14 squared is equal to 2 radical 85 squared. Now, I didn't show all my work here on this one, so I'm going to need my calculator again. 12 squared is 144. 14 squared is 196. And 2 radical 85 squared is 340. So 144 plus 196 gives me 340. So yes, it is a right triangle. Well, now the question is, find the length of the altitude from the to the hypotenuse. So now that we've established that this is a right triangle, we want to know how long is that altitude from the right angle to the hypotenuse. Now, I'm looking at this as really, at this point, I'm looking at it as just similar triangles. And I'm going to be able to say that 14 over x is equal to, it's the same ratio as 2 radical 85 over 12. I'm just looking at the corresponding sides. So 14 over x, that is the hypotenuse of the medium triangle to the short leg of the medium triangle, and then I'm looking at the hypotenuse of the large triangle to the short leg of the large triangle. Just setting up a proportion, and when I cross multiply to solve for x, I get about 9.1. That's about the altitude that we're going to be looking at on that one. And you'll do the same thing on 11 and 12. See if it's the right triangle first with the Pythagorean theorem, and if it is, find the altitude by writing a proportion with similar triangles. And 13, 14, and 15, I've been getting a lot of questions on these, but they're really the same thing. So again, as what I just did on 10. So here it's not, we don't have to figure out, is it a right triangle? They're telling us it is a right triangle. We have triangle ADC, we know it's a right triangle. And so DB is an altitude. We know that because it goes from the vertex and forms a right angle, so we know it's an altitude. So that means we have three similar triangles. We have a large, a medium, and a small triangle that will all be similar to each other. So find AC. Well, in this case, AC is really easy to do. It's the hypotenuse of the big triangle. And since I know the two legs of the big triangle, the Pythagorean theorem says that that's going to be 50 units long. Now that I know the triangle, or now that I know the one side that I needed, now I'm going to move on to BD. Okay, well in this case, BD, you can look at it as either the short leg of the medium triangle or it's the long leg of the small triangle, however you want to look at it. And I'm going to say the ratio of BD over 40 will be equal to the ratio of 30 over 50. And when I cross multiply, I get 24. So that's how we're looking at those. All right. Again, I have gotten quite a few questions on these, and the easiest way I thought to address them all would be to make this video. If you have any other questions that I wasn't able to address with these examples, please let me know, and I'll be happy to help you. But until then, I'll just keep waiting, see if you have any questions. Hopefully this helps. But thanks for watching. I hope this was helpful if you had questions, and talk to you later, guys.